Boyle. I'm the project manager for the Courtois Neuromod project. And the idea is actually to scan 6 participants really intensively in both the MRI scanner and the MEG scanner and see if we can use human brain data to get closer to something called generalized intelligence. What we have in the AI world is systems that are mathematically and computationally built. Often they do one task really, really well, but they struggle with other tasks. A really good example of this is video games. Artificial neural nets can often outperform humans in video games, but they don't really play in a natural way. An artificial neural net playing Mario Brothers, the way that it beats the system is by actually kind of gliding its way through as quickly as possible, and it doesn't like collect the pennies, for example. And if you played Mario Brothers as a child, you know that collecting those coins is part of your game. And so the idea is to get artificial neural nets to behave more like humans, so like we have this transfer of knowledge. It's just something that humans do really, really well and very naturally. It doesn't take 50,000 examples for a child to know the difference between a dog and a hot dog. One you eat, one you play with. But an artificial neural net can often take massive computational power and many examples before it understands that.
Video games are awesome because when you do video game, you're doing a vision task constantly. You're also doing a lot of planning and strategic thinking, but you're also taking decisions, several times a second. And we record that. We try to see, can we, from brain activity, predict what people were doing? We can break almost 90% accuracy with this type of architecture.
Yu Zhang, who's the lead postdoc on this collaboration with Dell and Intel, she was trying to work on a model called graph convolutional neural nets.
We have been involved like 2 computing systems to compare like how the performance was going.
So the lab relies on both servers that we have internally here, so we have a GPU server, but what we really rely on is Compute Canada. And Compute Canada was just not powerful enough to be able to run the models that Yu was trying to run. So it would take her days, weeks, it would crash, she would have to wait in line. Dell was visiting, and I was invited into the meeting very kindly.
And they told us that they had started working with a new type of hardware to train artificial neural nets. Dell's using traditional CPUs, pairing it with a new type of memory developed by Intel, which is called Octane. Their new CPU architectures are really optimized to do deep learning. So all of that sounded great, because we had this problem, we ran out of memory.
The innovation lab, having access to experts to help answer questions immediately, that's not something to negate.
We were able to train the AlexNet within 20 minutes. But before, if we do the same thing on the GPU, we need to wait almost for 3 hours to finish one apple.
We were able to train those traditional convolutional neural net.
Dell has been really great because anytime we need more memory, we send an email, Dell says, yeah, sure, no problem, we'll extend it, how much memory do you need? It's been really simple from our end. And I think it's really great to be at the edge of science and technology. We're not just doing the same old, we're pushing the boundaries. Like often we don't know where we're going to be in 6 months. Let's face it, in the big data world, computing power makes a big difference.